Hi, I'm Mr. V, and today I'm going to explain how we expand an expression to a difference of two squares. You'll notice I've got a difference here. So this is a subtraction sign, which means it's a difference. And we have two squares. So this x squared and this y squared are both squares. Since it's a difference of the one and the other, this is called a difference of squares. And this is the identity property of the difference of squares. So let me explain how this works. If I have an expression and its conjugate. Now the conjugate is not something, it's just a fancy word to say that we take the difference of one of the terms here. So if I have this term as a plus, this would be a minus. These two terms are conjugates of each other. And when I multiply them, I'm going to do this, expand this using the box. I have x plus 1 on the top. I'll put x minus 1 on the bottom. I have x squared. X times 1 is 1x. A negative 1 times x is a negative 1x. And a negative 1 times 1 is a negative 1. So I'm multiplying these two terms, and I'm adding everything in here. So this is like a length times a width, an area model, and this is what's left over. So if we take this, we have x squared plus 1x minus 1x minus 1. Notice these two are like terms. They both have an x in it. They don't have an x squared. They don't have just a number. They have an x in it. And it's a plus and a minus, so this goes to 0. So I end up with x squared minus 1. This is a difference of two squares. That's why they call this a difference of squares. When you multiply a binomial by its conjugate, where the one is a negative, you get this. You get the square of this one minus the square of the second term. Let's try this next one. And again, I'm going to use the box because I know that some of you struggle with trying to just remember simple rules. I want you to remember how to use the box. And this will get you out of any trouble if you have trouble with this. So 3a, and we have a minus 7. 3 times 3 is 9. A times a is a squared. 7 times 3 is 21. So we have 21 times a. Here we have a negative 7 times 3 is a negative 21a. Notice these two are like terms, and they cancel each other. They go to 0. And I have a negative 7 times a positive 7, which is a negative 49. When I add all of these together, I get 9a squared, which is the first two terms, the first term squared. Then I have a minus, because of a minus here, 49. The middle terms disappear. They subtract each other. They are additive opposites. And so this is my answer. But if this is a general case, I've got a 2 here, but I've got these variables, and we can still do this with variables. You can still do this with variables. 2m plus n times 2m minus n. Here we have 2 times 2 is 4. M times m is m squared. Then I have plus 2mn. Here we have a minus 2mn and a minus n squared. Again, these two are like terms, and they're additive opposites, so they go to 0. 2mn minus 2mn is 0. So I'm left with 4m squared minus n squared. And you could use the identity property of this to go directly to this if you recognize this as a term and its conjugate, or the conjugate of two terms. The property is, if you have these two and you're multiplying by it, you square the first term and you subtract the square of the second term. They call this a difference of squares, difference of two squares. Now, here's the question. What if x plus 2 is 6 and x minus 2 is, I can't see it. X minus 2 is 2. What is x squared minus 4? We don't have an x squared minus 4, but we do have x plus 2 and x minus 2. And if I multiply these two together, x plus 2 and x minus 2, this is a difference of squares. These two terms are conjugates of each other. And so I can go, this is x squared minus 4. If you need to use the box, you could use the box to expand it, but I'm just going to go directly to this because it's shorter. Well, what is x squared minus 4? It's this first term, which is 6, times this second term, which is 2, and I get 12. So my answer is 12. Finally, I want you not to be confused when I do this. This is not equal to x squared plus 1 squared 1. This is not the same. And I'll show you why. If I do the box here, I have x, and you can do this with any of these. You can use the box. Box is a area model. X times x is x squared. X times 1 is 1x. At 1 times x is 1x, and 1 times 1 is 1. These are like terms. When you combine them, they don't disappear. This is not true here. What it is equal to is x squared plus 2x plus 1. So don't get these confused. Don't mix up this with the difference of squares. The difference of squares being when you have a term and its conjugate and multiply them, you get 1 squared and another squared and the difference between them. That's today's lesson. Good luck and success.